Hello, welcome to Lian's presentation of image processing. My topic is object tracking based on mean shift and silhouette extraction. First, the definition of object tracking and tasks will be discussed, and then the mean shift theory will be introduced, and following will be the silhouette extraction tracking. And then the improvement in multiple object detection is reviewed. And then the the algorithms used in this project will be evaluated. And finally is the references. About the definition of object tracking, it is the process of locating a moving object over time using a camera. The objective of object tracking is to associate target objects in consecutive video frames. The common object location and representation algorithms include kernel-based tracking, such as mean shift tracking, and so forth, which is an iterative localization procedure based on the maximization of a similarity measure, and the silhouette tracking, which focuses on detection of object boundaries. The procedures of object tracking include detection of interested moving objects, tracking of such objects from frame to frame, and analysis of object tracks to recognize their behaviors. In this project, the focus is mainly in tracking interested objects. As for the mean shift theory, it is a tool for finding modes in data sample sets, manifesting the underlying probability density function in R to N space. And for data, we usually have two methods. Two kinds of method to measure it. The first one is the non-parametric density estimation, which is based on discrete PDF representation. The second one is a non-parametric density gradient estimation, which is the mean shift. Mean shift theory tracks object based on the gradient of interest point densities. Through iteration, the region with the largest density in eigenspace will be reached. As the mean shift method is kernel-based tracking method, so it uses kernel density estimation. Similar to probability density function, kernel function also has properties such as non-active unit integration and so forth. The first one, first the kernel function is normalized, and second, the kernel function is symmetric, and third, the kernel function is also exponentially weight decaying. The kernel function not only affects the property of the density estimation function, but also has great effect on the convergence and the efficiency of the mean shift method. Therefore, the selection of kernel function is very crucial. And here are some examples of the kernel function. The first one is the Epanakhnikov kernel, which is also used in this project. And the second one is the simplest one, the uniform kernel, and then the biweight kernel, and finally the normal kernel, also known as Gaussian kernel. The kernel, as for the principle of the kernel-based tracking, the kernel refers to the object shape and appearance. For example, the kernel can be in the shape of a rectangular template or an elliptical shape with an associated histogram. The objects are tracked by computing the motion of the kernel in consecutive frames. And the motion is usually in the form of transformation such as translation, rotation, and affine. Next, the silhouette tracking method will be discussed. As objects may have complex shapes such as hands, head, and shoulders that cannot be well described by simple geometric shapes, so mean-shaped method is not suitable for these cases. Silhouette-based methods provide an accurate shape description for these objects. And the silhouette tracking is performed by estimating the object region in each frame. And the silhouette tracking methods use the information encoded inside the object region. This information can be in the form of appearance density and the shape models, which are usually in the form of edge maps. Given the object models, silhouettes are tracked by either shape matching or contour evolution. The shape matching searches for the object silhouette in the current frame, and the contour tracking evolves an initial contour to its new position in the current frame. So the shape matching is a distance transform based matching. The silhouette is assumed to only translate from the current frame to the next. Therefore, non-rigid object motion is not explicitly handled. And here is the illustration of this method. In the scene image, we have several objects, and after the feature image and the silhouette extraction, the silhouettes of the objects will be extracted and compared with the predefined template. The object with the smallest error to the template will be viewed as the object defined by the template. As for the contour evolution, it iteratively evolves an initial contour in the previous frame to its new position in the current frame. This technique requires that some part of the object in the current frame overlaps with the object region in the previous frame. As we can see in this neighboring frames, the silhouette of the car changes over in different frames, but it is still accurately tracked. In this project, the contour evolution is used. Specifically, based on the difference between neighboring frames, the silhouettes of moving objects can be extracted. But there are some difficulties with this method. In close view, the moving object cannot be accurately extracted due to the large volume of detailed movements, such as the moving camera lens. And when there is occlusion in multiple objects, silhouettes may be inaccurate. And here are some tracking results obtained from this project. In the first image, we can see that the silhouettes of the moving objects are perfectly extracted. We need to note that this is a far view stable camera lens case. However, in the second image, the tracking result is not very good. This is a short view and moving camera lens case. As the moving object is quite near to the camera lens, some inner points of the moving object are thought to be static, so the overall boundary of the moving object is not accurately extracted. And the next, I'm gonna demo the programs. First, I run the main program, and I choose the main shift method, and I choose the case for object tracking. In the main shift method, we need to select region of interest first. I select the person as the interest frame region. I double click it. We can see that the interest region is perfectly tracked. And next, I'm going to show the silhouette tracking in this case. Select silhouette, then the Gangnam Style, and the video will be shown. In the second figure, the silhouettes are extracted and demonstrated like this. And this is the inner principle of this program. As we can see, the boundaries are extracted finely. And I use the main shift to track the second case, which is a short view unstable camera lens case. I select interest region. We can see that in the tracking process, the region is accurately tracked. However, when using silhouette extraction in this case, the result is not very good, since most parts of the interest object is not moving. So the evaluation. As for the main shift, there are some advantages. First, it is resistant to the detailed changes in the background. And second, it is reliable in tracking the predefined interested region. However, the major disadvantage of this method is the convergence rate problem. The convergence rate is highly dependent on the area of the selected region. And when interframe difference is abruptly large, there may be convergence problems, such as convergence failure and so forth. And as for the silhouette tracking, it has fine performance in tracking motion objects in remote view scenarios, and it is efficient and no convergence problem. However, in close view scenarios or scenarios with differing camera lens, it has very bad performance. And here are the references I used in this presentation. Thank you for watching this presentation.